Hey guys, let's look at this periodic functions review. For the first one, we want to try and write a formula for this periodic function in terms of sine, and then find those 5 indicated x values. So to write the function in terms of sine, we know that we're going to want to find the 4 major components if we think about the function in standard form as y is equal to a times the sine of the frequency times x minus the horizontal shift plus that midline. So now if we make a list of these things, so we need a, the amplitude, the frequency, the horizontal shift, and the midline. I think it's easiest to first find the midline, because if I look at the maximum value of 50 and we look at the minimum value of negative 30, the midline is going to be the x value that's the average of those two. So the x value the y value that's in the middle of those two is 10. So let's draw in this midline, 10. And now, with that, we can find that the amplitude is the distance that we go from the midline down to the minimum, from the midline up to the maximum. And that distance is 1, 2, 3, 4, so 40 or down 40. So our amplitude is 40. Now to find the horizontal shift, let's start on the midline and on the y-axis and look for the first place that we see a graph of sine. Well, in this case, there's a point on the midline on the y-axis, and it goes up to the maximum, all the way down to the minimum, and back to the midline. So that completes our first cycle for sine. So our horizontal shift is going to be 0. The length of that cycle was from 0 to 50 units. So the length of that cycle, the period, is 3. That helps us get the frequency, 2 pi divided by 50, or pi over 20. So now we can write our equation in standard form. Okay, so notice that I don't need to do x minus 0, because x minus 0 is just x. So x minus 0 just is simply x there. So we can write it as just the sine of pi over 25 times x. And now the second half of this question was to find those indicated x values. Now we just got a function for y in terms of sine, and all of these points here have a y value of 35. So what we're going to want to do is take this equation that we just solved for and set it equal to 35. So 40 whenever we solve a trigonometric equation, we want to get the trigonometric part by itself. So we're going to subtract 10 from both sides and then divide both sides by 40. So the sine of pi over 25x is equal to, in reduced terms, 0.625. So now it's time to find out what that angle is equal to. So pi over 25 is equal to the inverse sine of 0.625. At this point, I think that it would be easiest if we broke it up into 2 equations, because we know that we can find one of the angles that has a sine of 0.625 just by looking at our calculator. So pi over 25 x is equal to, well, our calculator tells us that this is 5.371. No, 0.675, sorry. I have a feeling I skipped ahead in my notes. So 0.675. Now, let's get x by itself. So we'll multiply both sides by 25 over pi. and x is equal to 5.371. Okay, but this was just one of the angles that had a sine of 0.625. So we can say that and pi over 25 x is equal to 2.6467. And we got that because we're looking on the unit circle for angles that have the same y value, pi minus 0.675. Multiply this by 25 over pi, and x is equal to 19.632. But the question asked us to find the 5 indicated x values, so let's just make a list of 5 x values. So we should have x1, x2, x3, x4, and x5. So let's go back to the picture and know that one of our x values is around 5 and the other one's around 19. So if we look, this is probably right around 5. And this is probably right around 19. So we found x2 and x3. But we want to find x1, x4, and x5. So by looking at x2, we know that the length of this cycle was 50 units. So 50 units away from x2 should be x4. So we can find x4 by adding 50 to x2. We can find x1 by adding 50 units to x5. To x3, sorry. And then also, if we wanted to find x1, we could subtract 50 units and get that x value. So we can find all of the others just by adding and subtracting. So let's go back down to our answers. So this was x2, 5.371. This was x3, 19.632. We said we could find x4 by adding 50 units here. So plus 50, and that's going to bring us to 55.371. We can find x5 by adding 50. So 69.632. And lastly, if we took our original 19 and we instead didn't add 50 but we subtracted 50, that would give us the value for x1. And that is negative 30.368. Okay, so there are those 5 x values. Question 2 is pretty similar, where I want to write a formula in terms of cosine and then find the 4 x values for which this function will be equal to 15. So again, standard form: amplitude, cosine, frequency, horizontal shift, plus the midline. If I make a list of this information, A, B, H, K, that midline, well, if we're oscillating between 10 and 50, that y value that's right in the middle is 30. Our amplitude is we go from the midline down 20 and from the midline up 20. Our horizontal shift. Now we're looking for cosine. Cosine starts at the maximum. So the first x value that we see our maximum is between 0 and 50, halfway between 0 and 50. So the first place that we see our maximum is shifted to the right 25 units. And then if b is equal to 2 pi divided by p, well, we can either find the distance from maximum to maximum, 25, to 125, or we can look for one cycle of sine. And both of those should be a horizontal distance of 100, so we get pi over 50. Plus 30. So there's our equation in standard form. We now want to set this equation equal to 15. So 20 times the cosine of pi over 50, x minus 25, plus 30 is equal to 15. Again, whenever we're solving a trigonometric equation, we want to get this part by itself. So the cosine of pi over 50 times x minus 25 is equal to negative 0.75. Now we're taking the inverse cosine. So that part that's inside, here, pi over 50 times x minus 25 is equal to the inverse cosine of negative 0.75. Let's get two equations. Pi over 50 times x minus 25 is equal to, the calculator told me that this was 2.419, so an angle of 2.419, and pi over 50 times x minus 25 is equal to 3.864. Now when we're working with cosine, we're looking for angles that have the same x value, so it's 2 pi, not pi, but 2 pi minus that acute angle, 2.419. We're going to solve this by multiplying both sides by 50 over pi. 50 over pi, x minus 25 is equal to 38.499. X is equal to, when we add over 25, 63.499. Multiply both sides by 50 over pi. X minus 25 is equal to 45.582. X is equal to 70.582. Okay, so these were two. We were asked to solve for 4 of them. So we know that there were 63 and 70-ish. So like taking a look at this graph, here's about 62, here's about 70-ish. So I'm looking for now, these y values were 15. So we have this one, which is like 60, and then the 70-ish. So we have to go over to these ones, which would be 100 units to the left. So we're going to subtract 100 from each of these. Subtract 100, subtract 100, and we get that x was also equal to negative 36.501. And when we subtract 100 from this one, x is equal to negative 29.418. So those are the 4x values for that one. Okay guys, this was questions 1 and 2. For questions 3 and 4, watch the next video. The next ones are all on solving, so we'll do some more like the second half of both of these questions.